alpha equals 40 degrees, A equals 25, B equals 36. We do not know the length of C. I draw a dotted line first at the base. We know that alpha is 40 degrees. It's a little bit less than half of a right angle. B is 36. I use 72 mm to represent the length with my ruler. The side opposite to alpha is A and is 25. I use 50 mm. I put down A equals 25. If I move my ruler around, there is another A, so I draw both of them. There is a big triangle and a small triangle, including alpha equals 40 degrees, B equals 36, and A equals 25. And C can be from alpha to this angle, and I will use the subscript C sub 1 to represent this triangle, and also beta sub 1, the angle opposite to B, gamma sub 1 to represent the information on the small triangle. For the big triangle, the base C sub 2 goes from here to there, and the angle correspondingly is beta sub 2 and gamma sub 2. The reason that there are two triangles, I will show you on the side here. I write down BA, and the angle opposite to A is alpha. We let the height be h. Using sine function, we have sine of alpha equals opposite over hypotenuse, which is h over b. Using cross multiplication, we have h equals b times sine of alpha. In regard to our specific information, I substitute in b and alpha to get h equals 25 times sine of 40 degrees. It is approximately 16.07, which is less than 25. That means we have another A here in the figure. That explains why we have two triangles. Using the law of sines, we have sine of beta over B equals sine of alpha over A. Substitute in the information, we have sine of beta over 36 equals sine of 40 degrees over 25. Multiply both sides by 36, we have sine of beta equals 36 times sine of 40 degrees over 25. We focus on the big triangle first. Beta sub 2 equal to arcsine of 36 times sine of 40 degrees over 25. Every time we make sure the calculator is in degree mode. Arcsine of 36 times sine of 40 degrees, close parentheses, divided by 25, close parentheses, equals. It is approximately 67.76 degrees. Then gamma sub 2 equals 180 degrees, subtract 40 degrees, minus beta. We press the AC button, 180, subtract 40, subtract the answer from the previous result, equals, which is approximately 72.24 degrees. Using the law of sines again, C sub 2 over sine of gamma sub 2 equals 25 over sine of 40 degrees. Using cross multiplication, we have C sub 2 equals 25 sine of gamma sub 2 over sine of 40 degrees. Press the AC button. 25 times sine the ANS button, close the parentheses, divided by sine of 40 degrees, close the parentheses, equals C sub 2 is approximately 37.04. Now we focus on the small triangle. Beta sub 1 equals 180 degrees minus beta sub 2. Beta sub 2 is simply a reference angle in this case, because sine function is positive in the first and second quadrant. It creates the scenario that there is a chance of having two triangles. Set the calculator in degree mode. 180. Subtract arcsine. 36 times sine 40. Close the parentheses. Divided by 25. Close the parentheses again. Equals beta sub 1 is approximately 112.24 degrees. Gamma sub 1 then equals 180 degrees. Subtract 40 degrees. Subtract beta sub 1. Press the AC button. 180. Subtract 40. Subtract ANS button. Equals gamma sub 1 is approximately 27.76 degrees. Using the law of sines again, C sub 1 over sine of gamma sub 1 equals 25 over sine of 40 degrees. Using cross multiplication, we have C sub 1 equals 25 times sine of gamma sub 1 over sine of 40 degrees. 25 times sine ANS button, close the parentheses, divided by sine 40, close the parentheses, equals C sub 1 is approximately 18.16